So we're moving forward with graphing polynomial functions. In the previous video, the functions were already in factored form. On this video, we're going to do two polynomial functions that need to be factored. Okay, so we've got a trinomial here, third degree trinomial. So it's a third degree function with a leading coefficient of +1. Okay, so we know our end behavior. As x approaches negative infinity, y will do the same. As x approaches positive infinity, y will do the same. Okay. Now, to find the zeros, we actually have to factor the trinomial here. So the first thing we want to do is take out the GCF. Each of the terms has an x in common. When you divide that x out, you're left with a quadratic trinomial, x squared minus 2x minus 3. Okay. That trinomial can be factored as the product of two binomials. When we factor that one, we get x plus 1, x minus 3. So we've got three factors there. Each factor occurs one time. So we're going to need that when we determine the multiplicity of each of the zeros. Okay. So first thing, the first factor x, we set it equal to 0. So that's going to be one of our x-intercepts, x equals 0. Second factor, multiplicity of 1. So we're going to cross the x-axis at that 0. Second factor, x plus 1, set it equal to 0. You solve, you get -1. That's again a multiplicity of 1. And the graph is going to cross the x-axis at that intercept. Okay. Third factor, x minus 3, set it equal to 0, so x equals 3. The factor occurs once, so it has a multiplicity of 1. Odd multiplicity means the graph crosses the x-axis at that location. Okay. So our three x-intercepts, all with a multiplicity of 1. So we know the graph is going to cross over the x-axis 3 times, right? Now the y-intercept has already been found, okay? The first x-intercept was at the origin, so that's also going to double as the y-intercept, okay? In standard form, you can always look at the constant here. There is no constant there that forces the y-intercept to be 0, okay? If there were a constant there, then the y-intercept would be that value, okay? So making our table of values here, we're going to go just to the left of -1. That's our smallest x-intercept, so I'm going to plug in -2. Do all the math that results in a -10 for my y value, or my f of x. So we get -10. So the point -2, -10 will be on the graph. Again, these extreme values here are the ones outside of our intercepts you don't have to find. I just like finding those to kind of make my graph a little more exact. Okay. Next table, or next value is going to be one of the zeros. We've already calculated that. Okay. The next value I want to find, we had a 0 at -1 and a 0 at 0. So I want to find a value in between there. So we're actually going to plug in -1/2 just to make sure I know where the graph's going to be there. Okay, math's not necessarily easy. Nobody likes fractions. But when I cube -1/2, I get -1/8. When I do this part right here, that leads to a -1/2. And when I multiply -3 times -1/2, I get +3/2. If you get a common denominator there and add those three fractions, you get 7/8. Okay, so the point -1/2, 7/8 will be on the graph. Okay. Next value is going to be my second 0 there at the origin. Okay, and that should say 0 there on f of x, not 6. I'll fix that in a little bit. Okay, next thing I want to do is plug in +1. All right, do all the work, and that leads to a -4. So the point 1, -4 would be on the graph. And then I want to plug in my next 0. I didn't plug in 2. Notice that. You could if you want to be a little more exact with your graph. But I just wanted, one value in there between 0 and 3. So the point 30 is on the graph. And I'm going to plug in 4 again, just outside of the final x-intercept there. When you do all the work, you get 20. Okay, so the point 4, 20 will be on the graph. Okay, let's look at how to graph though. We're going to plot those points and take a look at what that graph looks like. Okay, so to graph this function, we've got our zeros at -1, 0, and +3. Our y-intercept was at the origin as well. Okay, We know our end behavior, -2, -10 is going to go like this. And we know over here we're going to go like that. Our end behavior is down and to the left and up and to the right. Okay. Next value, -1 7/8. Okay, so we're -1/2, excuse me, 7/8. So we're going to be about right there. Okay, so we're not going very high. Notice, remember, we're going through the x-axis at each of these values. So this little part of the graph is just going to go up and then back down. Okay, we're going to cross the axis there and go to 1, -4, which is that value right there. So my graph's going to continue through there and then turn back up. So that's the graph of number 13. We're going to move on to number 14 now. We've got a third degree polynomial, 4 terms. I think we're going to be able to factor that by grouping. Let's make sure. If not, in the future, we're going to learn how to find the zeros of polynomials that can't be factored. Okay, so in behavior, we've got a third degree polynomial with a leading coefficient of +1. So we're going to continue with the same end behavior we've been dealing with so far. Okay, so now we're going to find the zeros by factoring. All right, so we're going to group together the first 2 terms and the last 2 terms. We're going to take a greatest common factor out of each, and we should be left with a binomial in common once we've done that. Okay, so the first binomial here has a greatest common factor of x squared, and this one has a greatest common factor of -4. Okay, so let's take those out, and it leaves us with this common binomial x minus 2. So we can factor this by grouping. As long as they have this binomial in common, then we're good to go. Okay. So once we put those together into 2 binomials, we got x squared minus 4, which can still be factored. That is a difference of squares times x minus 2. Okay. So once we factor that, we've got an x plus 2. This would factor as x plus 2, x minus 2. That leaves me with 2 of the x minus 2 squares. Okay. So next thing I want to do is set those factors equal to 0. So the first one, x plus 2, gives me a 0 of -2. This factor only occurs the one time, so it has a multiplicity of 1. So the graph will cross the x-axis there at -2. The second factor, though, occurs 2 times, an even number of times. That gives us a 0 of +2, a multiplicity of 2. So at that point, the graph's going to bounce off the x-axis. Okay? To find the y-intercept, we're going to plug in 0. Okay, we're going to do all the math. Or remember, when we're in standard form, we can just look for this constant here. So the y-intercept should be +8, and that's what we find here. Okay, now we're going to do our test values, and then we'll be able to graph. So hopefully we're moving quicker through these this time. All right, so our smallest x-intercept was -2. I'm going to go a little bit to the left of that, so -3. Plug it into the original function, do the math, and I get -25. Okay, so the point -3, -25 is on the graph. Okay, we know the next value is going to be my x-intercept, the smallest one, -2. Okay, now I'm going to plug in -1 just to see where we are on the graph. Okay, I'm going to get -1, +9. Okay, so at that point we'll be on the graph. The next point should be my y-intercept. We're just going in ascending order by x values here. So that's 0, 8. We already found that. I'm going to plug in +1 now. Okay, when I plug in +1, I get a 3. All right, so 1, 3 should be on the graph. Next point, I'm going to plug in 2. That was my second x-intercept. So 2, 0 should be on the graph. And then just to verify that we've bounced off the axis there, I'm going to plug in 3 and see what we get when we plug that into the original function. And I get a +5. Okay, so the 0.35 should be on the graph. Okay, so we're going to plot those points and take a look at what that graph looks like. All right, so the graph here for number 14, we've got 2 intercepts. The x-intercepts, one at -2 and one at +2 here. We've got our y-intercept up here at +8. Okay, we know our end behavior. We're going to go down here. We're going to go up here. Okay, so we've got a few more points we want to plot here. We had -3, -25. That would be taken care of with our end behavior. Same thing with 3, 5 here. Okay, so -1, +9. I want to plot that one just to have a clearer idea of what's happening. Remember, this x-intercept had a multiplicity of 1, so we should be crossing the x-axis, which we are. Okay, and I want to start coming back down to that y-intercept. When I plugged in +1, I got 3. So we're going to plot that point there. Okay, so we're coming down here. Remember, at this x-intercept, we had a multiplicity of 2. So that's why the graph bounces off the x-axis and starts to head back up. Okay, so hopefully you're learning about how multiplicity changes the graph. We're crossing the axis there, bouncing off the axis there. And there you have it.